Hey everyone, in this video we're going to be looking at how to simplify complex radicals. So to simplify radicals we use something called the tree method. And on every tree we see branches and we also see leaves. So that's mainly what the tree method is about. So let's go back to our equation, 3xy. And then 5 root negative 64, x to the power 8, y, z to the power 4. So the first step to simplify this radical is to break everything up under the radical sign. So let's start breaking them up into their components. So first we have the negative sign, so 5 root negative 1. When we have a negative number, as the radicand is the number that is under the radical sign, and 5 is the index. So we put the radicand, -1, and 5 as the power. So -1 to the power of 5. And this can be displayed as -1 times -1 times -1 times -1 times -1, which equals -1. But we could also realize that whenever you have a negative number raised to an odd integer, you are going to get a negative number. So you don't have to show all the negative ones multiplying themselves. So that saves you work and time. Our next component is the 64. So we're going to use our basics on how to, simplify this using the tree method. So we create the branches here. So we have 2 branches, so right here and right here. And then we have 8, perfect, that gives us 84. And then we have, simplified them to their prime number. So 2 is a prime number. Prime numbers are those that multiply by themselves, and 1 only, that have the factors of 1 of themselves only, rather. And then we group them based on their index. So we group 5 2's together, and then we're going to have one of the 2's from the group of 5 on the outside. Draw your radical sign and the index, and then place the 2 that's remaining on the inside. All right, going on to x to the power of 8. To do this, we're going to go back to our previous math years where we've done something like this. So 8 divided by 5, we have our remainder here as 3. So remainder, and here above we have our quotient. So it's important to note that the quotient goes on the outside, the remainder goes on the inside. So what do I mean by this? So you're going to write your variable. So we have our variable x here. We have the 1 from over here coming on the outside. Draw your radical sign and write your index. Then you're going to have the variable raised to the power of 3, and that's our remainder. So quotient goes on the outside, remainder inside. Now we have y to the power 1 under the 5 root. So to do this, we're going to do the same thing. 5, do the division. 1 divided by 5, you're going to get 0 on the top. Outside has the quotient, 1 on the bottom. That is your remainder, and that goes on the inside. So 0 outside, 1 inside. So really this right over here, anything raised to the 0 power is just 1. 1 times index 5, so 5 root y. So anything to the power of 1 is itself, so y. So this really equals 5 root y. And you can really see that here. Okay. But isn't that the same thing as what we originally had? We had y, and then we had 5 root. we didn't simplify anything if that's what you're saying, trying to ask. Well, that's because we come to this very important rule. So, and that is if the power under the radical sign is less than the root, it does not change. And that's what we saw here. So when you have something like this and you do your division, like in the previous slide, it equals itself. So just make sure you, understand that rule so that you don't have to show extra work or you don't waste time on your quiz or test. Z to the 4, so we have 5. So we have 5 root z to the 4. Well, the 4 is less than 5. So in this case, our power is less than the root. So we have no change, just like what we saw in the previous slide. So it's going to remain the same. Perfect. So this is what we have for each component. So we're going to start off with the outsides, like the components on the outsides. So -1, 2, and x. So we're just going to multiply them out, and you're going to get -2x. But this is not your final answer, because remember, we have 3xy up here on the top. So you're going to bring that over here, multiply the -2x that we got from our previous slide over here, bring it over here, times 3x, and you're going to get -6x squared y for the outside. Now for the insides, all you have to do is multiply them together. So 2 times x times y times z to the 4. And we have that over here. And then just combine the outsides and the insides together. So we have our inside, and this is our outside. And this is your final answer.